Hello guys, welcome back to our YouTube channel ABCS preparation site. So guys, this is our third chapter of GRE Quant section, which is integers. So now we'll move on to the content. Before that, if you're new to our channel, please subscribe our channel so that you will not miss the upcoming content of our channel. So let's start the questions. So our first question is, if k is an integer and k equal to 462 divided by n, then which of the following could be the value of n? See, it mentioned here k is an integer and given k equal to 462 by n. So k could be minus 3 minus 2 minus 1 0 1 2 3 . So these are the possible value of k. So for getting the k integer value, the n should be a number which perfectly divide the 462. So we have to check each answer choices one by one if it is divided the 462 perfectly or not. So first check for 462 divided by 4, it become 115.5. it's not a integer value, so this is not our choice. See, our next choice is 5. By seeing the 5, we can easily conclude that this is not our choice, because for divided by 5 the unit digits should be 0 or 5, and that's it is not here. That's why it's not divisible by 5 also. Now check 9. 462 divided by 9, it become 51.33. This is not an integer, so 9 is also not our choice. Now check for 13. 462 divided by 13, it become 35.54. so it is also not an integer value. This one is also eliminated. Now our choice remain is 22, so that will be our answer, but we can check it also. 462 divided by 22 is equal to, it become 21, so it is an integer value, so our possible choice is 22. Our next problem is, the greatest prime factor of 40,002 is x and the greatest prime factor of 80,004 is y. So we have to find out for column A x value and for column B y value. So x and y are both the greatest prime factor of each condition. So first see here, 40,002, we have to find out the greatest prime factor of this condition, and for 80,004 we need to find out the greatest prime factor of this. So there is no need to find out the factor of both. We can make it simple. First make it equal to divided by 40,002. See, so this and this become same, and 2 is not the greatest prime factor of any number, right? It is the least greatest factor. If it is same, then see here, it is also divided by 2, 20,001, and this one is also divided by 2, it become 20,001. So whatever the value will become for both condition will be same. We can conclude that x is equal to y, and that's why we choose the option C. Next question is, if k is an odd integer, which of the following must be an even integer? So condition is given that k is an odd integer, so we have to find out the even integer which must be. Must be means in every condition it equal to the even integer. So k will be positive or negative, because there is no mention here that it is positive odd integer or negative odd integer. That's why we have to consider the both. 1 3 5. So we have to analyze the each answer choice properly. Let's consider for this k equal to 3. Okay, so 3 square minus 4 will be 9 minus 4 equal to 5. So that is an odd, so this is not our valid condition. Now see for next choice, let's make it 3 into k value 3 plus 2, that will become 9 plus 2 is equal to 11. This is also an odd integer, so that's why this is not our choice. So now see next, 2 into 3 plus 1 equal to 7. so that is also not our choice. Next, instead of putting the k value, first we will make it simple, okay, then we will consider the k value. 12 by 8 k, that will become 4 3 times 2 times, it will become 3 by 2 k. So if we put k value, it will always came on decimal form, that is 1.5 k. Okay, so now see for next choice, see here it become 2k. So when put k value, when k is equal to 1, it become 2, that's an even. When k become 3, it also become even. So in each answer choices, it always came even number, that's why it's our choice, and this one is eliminated. See here, our next question is y equal to 5 into 6 into 14 into 15. Okay, for column A we have to find out the remainder when y is divided by 18, and for column B we have to find out the remainder when y is divided by 40. So let's analyze each condition one by one. We given 5 into 6 into 14 into 15 and it is divided by 18. So now 6 1 and 6 3, right, and 3 1 and 3 5 times. So number is perfectly divisible by 18, so remainder will be 0. And see here, 5 into 6 into 14 into 15 divided by 40. So 5 1 5 8 times, then 2 4 2 7, right, again 2, then 3. See here, there is no number remain which is divisible by 2, so it is not perfectly divisible, so remainder will be some value, but we don't know what will be the value, right, we have to find out. So there is no need to calculate the remainder value, because whatever the value it came here remainder, it is a number which is always greater than 0. So our choice will become option B. So our next question is, when positive integer k is divided by 5, the remainder is 2. And next, when k is divided by 6, the remainder is 5. If k is less than 40 value, what is the remainder when k is divided by 7? So we have to see the each condition. When k is divided by 5, the remainder is 2. Right, and when k is divided by 6, the remainder is 5. From first and second condition we can analyze that the k value should be that one which is divisible by 6 and 5, and leave the remainder also different, 5 and 2 respectively. So k will be become 1 into 6 and remainder is 5, that's why we add 5, it will become 11. But when 11 divided by 5, the remainder will not be 2, that's why it's not valid. So let's consider second condition. 2 into 6 plus 5, it will become 17. When 17 is divided by 5, the remainder will be 2. So first condition is also valid for this value. So let's consider the k value is 17. So now check what is the remainder when k is divided by 7. So when 17 is divided by 7, 2 times become 14 and remainder will be 3. So our answer choice is third option 3. Here is our next question. X and y are integers greater than 5. X and y value are greater than 5. And next, x equal to y% of x square. So move down. For column A we need to find out the x value, and column B is given already 10 value. We'll make this equation more simple. So x equal to y by 100 into x square. So it will become x by x square is equal to y by 100, that is 1 by x is equal to y by 100, and x equal to 100 by y. So here column A become 100 by y. So from above condition y are integer greater than 5, right? And x is also an integer. So whatever the value for x came, it should be an integer and y should be greater than 5. But it perfectly divides the 100. So what are the possible value of y? 10, right? So x become 100 by 10 is equal to 10. Next y will be 20. So 100 by 20 is equal to 5. See, but this is not a valid because the x and y are both greater than 5. So this is not our valid condition. There is only one possibility, that y is 10 and x is also 10 and column B is also 10. So column A and column B both are equal. So our answer choice is C. So our next question is, when Q is divided by W, the quotient is R and the remainder is E. Which of the following expression is equal to E? So we have to find out the E from here. See here, when Q is divided by W, right? The quotient is R and the remainder is E. So the Q will become WR plus E, right? So from here we have to find out the E value. So E become Q minus WR. So our answer choice is third option, Q minus RW. Here is our next question. N is a positive integer. N is not divisible by 4. N is not divisible by 5. So remainder when N is divided by 4 and remainder when N is divided by 5. So from above condition we can analyze that N could be any value, right? Right, like 1, 2, 3, 7, 9, any value, right? So let's consider 1. What will be the remainder? 1 is divided by 4. Remainder will be 1. And here also, if 1 is divided by 5, then remainder will be 1. So in both condition, both are equal. What if the N is 9? Let's see. 9 divided by 4, the remainder will be 1. And 9 divided by 5, the remainder will be 4. And for this condition, quantity B is greater. So there is no relation between column A and column B. We cannot determine what the relation exactly between them. That's why we have to choose the option D. Our next question is, when positive integer k is divided by 1869, the remainder is 102. What is the remainder when k is divided by 89? See, the positive integer k, if divided by 189, the remainder will become 102. So the k will be 1869 times 1 plus 102. It could be 2 times also, 3 times also, but let's consider 1, okay? So that it will be easy for us to find out. Because if you consider 2 also, the condition will become same. We'll get the same value when k divided by 89. So don't worry about it. Let's consider any one value. So here we consider just 1 and it will become 1971. So now divide 1971 divided by 89. 89 2 times become 178, then 911. Then again divide by 2, it is 178, that will become 31. So the remainder will 13. So our answer choice is third option. Here is our next question. X and y are prime numbers and given x plus y is equal to 18. So for column A we need to find out the y value, and column B it's given 14. So what are the prime numbers? First we see here. Prime number are 2, 3, 5, 7, 11, 13, 17, ... So from this equation x plus y is equal to 18, right? So x plus y is equal to 18. So the possibilities of value that make the summation of 18 are 5 plus 13 and another is 7 plus 11. So one is 5 plus 13, that will become 18, or 13 plus 5 is equal to 18. Next value is 7 plus 11 is equal to 18, or 11 plus 7 is equal to 18. So the y possible values are 13, 11, 5 and 7, but all these values are less than 14. So column B is always greater. So our answer choice is B. Here is our next question. The column A is given. We have to find out the remainder when positive integer x is divided by 11. And for column B, 11 is given. So see here, this question we can just by seeing we can solve it without using a pen also. But I will tell you that how to analyze that situation. See here, the k is a number. When divided by 11, we have to find out the remainder. See, the remainder is always gonna be less than 11, because if remainder reach 11, it is divisible by 11, right? So the remainder will become 0. So the possibility of remainder values will be 0, 1, 2 to 10, but not 11. So the column A is always gonna less than column B. So that's why the column B is greater. So we have to choose the option B. Our next question is column A is given. We have to find out the number of prime numbers divisible by 13, and for column B we have to find out the number of prime numbers divisible by 2. See here properly, the prime numbers. Prime numbers are always divisible by same number only, not by other numbers. So the possibility of prime number are 1 only, right? That is 13 only itself. 13 is also only divisible by 13. If other number is divisible by 13, then that number will not be a prime number. So the number of prime numbers possibility will be 1 here, and here also 2 is divisible by 2 only, because the same condition is applicable as the column A, and that's why the number of prime numbers are 1 only, and both are equal. Answer choice will be option C. Our next question is for column A, we need to find out the number of primes between 50 and 60, and here also we have to find out for column B the number of primes between 80 and 90. So prime number between 50 and 60 are 53 and 59, only 2. Here also the possible choices are 83 and 89. So the number of primes here are only 2, and here also only 2. So both are equal. So option will be C. Here is our next question. For column A, we need to find out the product of even integers from -12 to 6 inclusive, and we have to find out the product of odd integers from -5 to 13 inclusive. See here also we can easily determine this value. Even integer. In even integer, 0 will always come. So here from negative to positive, in between this value there will be 0, and when any number multiply by 0, it will become 0 only. So the value of this will be 0. And for this here, the product of odd integer, the odd integer will be -5, -3, -1, 1, 3, 5, we have to multiply, but here it is 3 negative sign. So multiplication always give the negative value, whatever the value will be, but it is in negative form. So negative value is always less than 0. That's why the column A become greater, and our answer choice will be A. Here is our next question. M is a positive 2-digit number. When digits are reversed, the number is n. If k equal to m plus n, then which of the following is true? See here, m equal to any number, any 2-digit number. Let's consider 1, 2. And n is the number that is reverse, that will become 2, 1, right? When m and n added, it will become k. 12 plus 21, it will become 33. So which of the following is true? So remember this condition: when any two-digit number reversed and added with each other, then that number is always divisible by 11. Remember it. You can try any number, that number is always gonna be divisible by 11. So without wasting your time, you can choose. This is our choice. So k must be divisible by 11. So guys, this is our end of the chapter 3, that is an integer chapter. So we'll meet on the next video of the next chapter of GRE Quant. Till then, goodbye, take care, and don't forget to subscribe our channel